In this lesson, we are going to look at the matrices. So begin by defining what a matrix is. So a matrix, it is just an array of numbers arranged in rows and columns. Okay, so now the word matrix, this is singular. The plural for matrix is matrices. Okay, so now here, let's say we have a matrix A. So first I want us first we need to know how to identify the rows. Then we also have to look at how we can identify the columns. So the rows are horizontal, so we have these, the horizontal lines. This denotes the rows. Then we also have to look at the columns. The columns are vertical lines. So we have the vertical lines. These are known as the columns. Then from there, we may encounter a question where we are asked to find the order of a matrix. So order of a matrix. So order of a matrix is given by stating the number of rows followed by the number of columns. So we need to begin by giving the number of rows followed by the number of columns. So this is how you state the order of a matrix. So here we have matrix A, where we have 7 and 2. Then if the question is find the order of matrix A, we need to begin by giving the number of rows by the number of columns. So from matrix A, we can see that we have 2 rows, so it's 2 by then 1 column. So this is a 2 by 1 matrix. Let's try another one. Let's say we have matrix B. So the order of matrix B, you begin by stating the number of rows followed by the number of columns. So from here we can see that we have we have 2 rows by, let's look at the number of columns. So we also have now 2. So this is a 2 by 2 matrix. Okay, let's try another example. We have matrix C. So you can pause the video and give it a try. So the order of matrix C is you need to identify the number of the rows under this matrix. So you can see that we have 2 rows. Then after giving the number of rows, you need to state the number of columns. So we have 1, 2, 3. So this is a 2 by 3 matrix. Now after knowing the order of a matrix, let's look at how we can find the position of a number in a given matrix. So we have this matrix. So let's first begin by giving the order of this matrix. So first we need to find the number of rows, then and also the columns. So we can see that we have 1, 2, 3. We have 3 rows. Then we also have 1, 2, 3 columns. So this is a 3 by 3 matrix. Now you may encounter a question like this, where we have the subscript like 2 and 1. So the first number here, this represents the position of the row. Then 1 here, this is the column position. So here we want to find the number that is on second row, but on first column. So let's look at the second our second row. This is our second row. Then we are going to look at now our first column. So our first column, this is our first column. So the number where the second row is intersecting the first column is the number that we are interested in. So that is how to determine the position of a number in a certain matrix. So our answer here, we have 5. Okay, let's say try this one. So we go to, let's find the number on the second row, third column. So this is our second row, third column. So here we can see that we have a 12. What of this one? So under this one, we are looking at the number on the third row, second column. So third row, this is our third row, second column, this is our second column. So the number is 7. Since 7 is on the third row, second column. So that is how to find the position of a certain number in a given matrix. Now, away from there, there is what we call a row matrix. So now, how do we know that this is a row matrix? So a row matrix is any matrix that has only one row. So regardless of the number of columns, as long as there is only one row, that matrix qualifies to be a row matrix. For example, if we have matrix A, so this is a row matrix, this is a row matrix, this is also a row matrix. So what we mean by row matrix, it is just any matrix that has only one row. So from there, the matrix A, we can see that the order is 1 by 2. Then matrix B, it's 1 by 3. Matrix C, it's 1 by 4. So we can see that we are not interested in how many number of columns we have under row matrix. So as long as the number of rows, if we only have one row in a given matrix, that matrix qualifies to be a row matrix. So what we are saying is a row matrix is any matrix that has only one row. Then away from there, we also have what we call a column matrix. So a column matrix, this one, it is just like the reverse of a row matrix. Here we only has only one column. So whenever you encounter a matrix where you have one column, but the number of rows here does not matter. So if maybe we have this matrix where we have entries like this, so you can see that we have 2 by 1. So this is a column matrix because there is only one column. Okay, so if we are to give this matrix, it's 3 by 1. So this is also a column matrix. So a column matrix is a matrix that has only one column. Now, away from the row and column matrix, there is what we call a square matrix. So a square matrix, this is the type of a matrix where the number of rows equals the number of columns. So if you have a matrix where maybe you have a 2 by 2, 3 by 3, 4 by 4, that is what we call a square matrix, since the number of rows equals the number of columns. For example, okay, so now if we were to give the order of matrix A, so here we can see that this is a 2 by 2 matrix. We have 2 rows and 2 columns. Then the order of matrix B, this is a 3 by 3 matrix. So as we can see, for a square matrix is any matrix where the number of rows equals the number of columns. Now, away from the square matrix, we may also have what we call equal matrix. So let's look at the equal matrix, or we just say equal matrices since we are looking at more than one. So for matrices to qualify to be equal, their corresponding elements must be equal. They need to have the same order, and also their corresponding elements must be equal. For example, if we have matrix A with elements then another matrix B, so here we can see that the first one, we can look at the order. So this is a 2 by 2 matrix, and also this is a 2 by 2 matrix. So the first step for two matrices to be equal, they need to have the same order. So we have seen that we have the same order. Then we also have to look at if the corresponding elements are equal. So we can look at the number, which is we'll say A1, so first row, first column is 5. Let's look at B11, first row, first column, there is also 5. So you can see that the first number is corresponding, or we have the equal. Then let's look at this one, first row, second column, we have 4. B, first row, second column, here we have 4. Then let's look at A, second row, first column is 4. B, second row, first column is 4. A, second row, second column is 6. B, second row, second column is also 6. So these two matrices are equal since their corresponding elements are equal. So this is what we call the equal matrices. Now let's look at an example how we can solve matrices with the concept of equal matrix. So we have matrix P is equal to this and Q. Then the question is find the values of X and Y for which P is equal to Q. So let's look at P row 1 column 1. So here we have 3x. Let's also look at Q row 1 column 1. So that is also equal to 12. So we can see that since on row 1 column 1 for P is 3x and row 1 column 1 for Q is 12. So what this means is these two corresponding elements must be equal. So x represents a number that if we multiply that number must also is equal to 12. So what you are saying is there is a missing value represented by x such that if we multiply that missing value times 3, this whole thing must be equal to 12 so that we have the corresponding element C where we should have equal. So what this means is we can see that where there is x, this must be 4. We know that 4 times 3 is 12. Now how do we solve a question like this one? So we are saying this element must correspond to this element. So what we are going to do is you need to say 3x is equal to 12. So you just have to solve it the way we do with equations. So since we are solving for x, we divide by 3 and also here by 3. Then we can see that x is equal to 4. Since we know that if we substitute where there is x with 4, we are able to get the 12, which is corresponding to the Q 1. Now let's also solve for y. So we can see that our y is here. So this is corresponding to this value. So we can look at the position for y. So position for y, that is row 2 column 2. So this is negative for y. Then Q row 2 column 2, that is 10. So this can be solved as negative 4y is equal to 10. So in order to isolate y, we need to divide by negative 4 and also here by negative 4. So y is equal to, we can reduce 2 into 10 is 5 over 2 into 4, that is just 2. So we have y is equal to negative 5 over 2, or we can just say y is equal to 2 into 4 is 2. Okay, so 2 into 4 is 2, remainder 1 over 2. If we want to leave our answer as a decimal, this is negative 2.5, because we know that if we multiply negative 2.5 by negative 4, we still get our 10. So this is how you can solve for missing numbers if you have been given matrices where you have been given a condition of the two matrices being equal. Now let's look at the last part. So the last part, we are just going to look at how to find the transpose of a matrix. So transpose of a matrix is given by you interchange the row becomes columns and the columns becomes the rows. For example, if we are given this matrix, matrix A is equal to so the order of this matrix is 2 by 3. So after finding the transpose for A, even the order will change. So the order will become 3 by 2 matrix. So the transpose of matrix A is denoted by A, then you put T like a power. Then what we are saying is this row, our first row, becomes the column, become our first column. So we have 6, 4, 3. Then our second row becomes our second column. So this will be 2, 9, 1. So this is now the transpose of matrix A. You can see that the order now becomes, so here we have 3 rows, then 2 columns. So after finding the transpose of a given matrix, the order also changes. Okay, let's say maybe if we have a square matrix. Now for this matrix, since the order is a 2 by 2, we can see that we have a square matrix where the number of rows equals the number of columns. So under this one, even for a transpose, the number of rows and the number of columns will be equal. So for a square matrix, the order does not change. So we have transpose B. So we are going to interchange. The rows becomes the columns. So 6, 8, 7, 7. So you can see that the order is still 2 by 2 matrix. So this is how you should find transpose of a matrix. So that's it for this video. Thanks for watching. Comment and like the video.